Ahoy, ahoy, my spooky friends. Happy early Halloween. Hope you all are doing well. And welcome to this special Halloween themed live stream here. Now, I'm hoping that you can kind of see this, but I do have a little bit of a smoky effect going on right now. And I got to adjust it. So it's what it really is just my humidifier, which is like I've been using the humidifier a lot the last couple of days because I've been sick. Oh, there we go. Now you can start to see a little bit. So tonight's going to be a little bit of a fun stream. So as you can tell, I am wearing my captain's hat. And so I'll explain that here in a little bit, but it's my pseudo costume I teased it earlier this week. Before jumping in, I do want to note I have had RSV this whole week. I know RSV is typically something that just kids get, but it's been going around here quite a bit lately. And so RSV is basically like if you take a cold and then smash it together with some stomach flu-like symptoms. So basically it's felt like I've had both of them. And so like it's been on and off for like the last few days. And so I'm doing all right now, but I don't know how long I'm going to be able to go in the stream before I like start to give out. So you might be wondering, well, why the captain hat? So we are going to be doing some data visualizations with a Halloween candy data set. And in order to do those visualizations, we're going to be doing them in Python. And the libraries that we're going to be using them for that are Matplotlib and Seaborn. So I thought it'd be funny, just as like a special Halloween thing, to have a sea captain's hat because we're going to be working with Seaborn tonight. So, by the way, I do have the candle on back there, but I actually haven't lit this candle in a really long time, and I lit it like a couple nights ago, and it made my whole office super, super like legit smoky. So I may have to stand up at some point and go blow that thing out. But for now, I'm just setting the vibe. Like this is the Halloween special. So I hope you have fun tonight. So, like I said, what we are going to be doing tonight is I've already actually written this whole thing as a blog post, and it's published out there on Toward Data Science. Everything that I'm going to be covering tonight is already written in code, and the whole thing. In that particular blog post, I cover 8 different visualizations types. I'm not going to get through all 8 in the stream. In fact, I'm just going to pick out the ones that I think are the most interesting. We'll just see how far we get. So, let's go ahead and share my screen here. Okay, so I have started a new Jupyter notebook that we're going to be working out of tonight. By the way, I did not realize that you can actually, through a third-party like little extension thing, you can actually theme your Jupyter notebook. So I actually found a dark mode kind of theme. By the way, I am monitoring the comments on both LinkedIn and YouTube for questions. So if you have any, feel free to reach out. And I can already feel myself getting a tiny bit winded. So hopefully we'll be able to do some fun stuff tonight. So anyway, we're just gonna start off with a notebook. And so I guess I should give a full credit to where this data set is coming from. In fact, let me go ahead and do like a quick search for it. So Kaggle Halloween candy. Okay, so this is the data set that we're going to be working with. So this is a data set curated by 538. And so it is basically it's this data set that has a number of different features about like the different candy and then like the different sugar and price percentage. And what they basically did, this last one is the most interesting feature of all, is they basically paired each candy up. I don't know exactly if it was like randomly or how they necessarily did it. And then like, so this is actually the percentage of each time a particular candy won. And so it looks like there were 269,000 matchups. So big thank you to Kaggle, 538 for curating this data set that you can find on Kaggle. I do want to note here that because I guess the one thing that I've tried to do, but I kind of forget to call out more often, and it's just to note that whenever you work with data that you don't curate yourself, you need to be careful or mindful of the fact that you are giving proper acknowledgement and stuff, or that you are allowed to use it. So this particular data set is covered by an appropriate MIT license that says that I am allowed to use it. So and I do just want to extend my gratitude again to 538 for putting together this data set. I genuinely do appreciate that. Okay, so I already do have this downloaded to my desktop, and I am going to go ahead and pop back in the Jupyter Notebook, and let's get the ball rolling here. Okay, so the first thing that we're going to need to do is importing the necessary libraries. So I already do have these installed on my machine. So we are going to be using, I'm going to import pandas because we're going to be using the pandas data, or loading the data as a pandas data frame. and then I'm going to import Seaborn as SB. Now, honestly, so this is, if you're not familiar, this is called aliasing, so where we are basically referring to Seaborn as SB or Pandas as PD. This is very common. Actually, the more common aliasing for Seaborn is actually SNS. I don't know why, and I don't like it, frankly. Like, I don't like it just because, like, when I think SNS, I think of like, you know, the simple notification service, Amazon simple notification service. And also, I mean, there might be a reason why it's alias that, but I don't see where you would get the SNS. There's not even two S's in here. So I'm going to call it SB, just because I personally think that's a little bit more intuitive. And then the third library that we're going to be importing here is Matplotlib. So we're going to do matplotlib.pyplot as PLT. All right. Now, one thing that we do need to do in order to actually visualize the visualizations or the data visualizations within this Jupyter Notebook here is that we do have to enable what we call a Jupyter Magic command, and that's going to allow us to actually show the visualizations here within the Jupyter Notebook. So there are a number of different magic commands in Jupyter if you're not familiar. I think the only other common one that I've used is the time one, that it basically just shows how long a cell ran when actually executing it. So the magic command that we are going to enable here is we started with a percentage sign, and it's matplotlib inline. Okay, so there's that. And now I need to import my data set. So I'm going to call this dfcandy. dfcandy equals pd.read csv. All right, so it's in my data directory, and then, yep, candy.data.cfc. And let's just go ahead and take a quick look at it so we can familiarize ourselves a little bit with the data. Now, to be completely transparent, when I had this idea of creating this notebook for visualizations with this Candy data set, I did not really look super close at this data. And so you can see there are a lot of features in here that are just binary variables. So like basically like these 9 here, chocolatey, fruity, caramel, these are all just represent, the zeros representing, you know, it is not. So like this, I have no idea what this is. 1 dime and 1 quarter like a legit candy. I've honestly never heard of that. So so zeros all the way down, or 1. So 1 is basically saying, okay, so 3 Musketeers is chocolate. So yeah, we'll just stick with the ones I know. So 3 Musketeers, we definitely know is chocolate. Airheads is not. We do know Airheads is fruity. And then you could see like on down the line. So then where it starts to get a little bit different is with the percentile based variables down here. And that is, so this is the, basically representing that this is more sugary than not. So whatever these 1 dime and 1 quarter things are apparently not very sugary. And then when you look at the price point here, so 100 grand is apparently higher on the price end compared to like 3 Musketeers. So again, this is percentile compared to the other candies of the price. This is not actually the actual prices themselves. So just to be aware of that. And then finally we have the win percentage. So this is the field where representing where, okay, like how often did a particular candy do against a different opponent. So we could see here apparently whatever these 1 dime and 1 quarters are here, it didn't really fare super well. I'm gonna guess they probably didn't fare well because I've literally never heard of them. And speaking of that, so I guess one fun thing I should do here real quick before we continue on is my wife was nice enough to because I mentioned before in previous live streams that my favorite candy was the M&M coffee nut variety, and I say was because I have not found it on the shelves in like 6 months. I'm pretty sure it was discontinued, so that's kind of sad. I would say my favorite candy bar is the Zero bar. So I don't have a Zero bar with me, but I would say my favorite seasonal candy, and I call it seasonal because I don't think, well, maybe you can get it year round, but anytime Reese's does like a Reese's egg or a Reese's pumpkin, I think these things are really freaking good. So I'm going to eat this right now. And a big thank you again to my wife for getting this for me. Oh, that was kind of chocolatey. I don't have any napkins on me. These are good. And I think, so I like all Reese's to be honest, but I think there's just something about the pumpkin and the egg that the ratio of the chocolate to peanut butter is just like perfect in these things. So yeah, that's dang good. That's really freaking good. All right, let's get back to this. And I'm also with this whole like RSV thing I've had, like I've been super nauseous lately, so like I've had zero desire to eat anything. So like today is like the first day when I felt good enough to actually eat anything. So this is a welcome treat. Okay, I'm sure you didn't want to see me do that or listen to my mouth though. All right, so that is the data that we're going to be working with. So naturally, you can expect that we're going to be pretty much working with all these different variables at one point in time. Oh, I guess the one thing I should note, if you're curious, because all these are pretty self-explanatory. Let me chew this in my mouth. You probably don't want to hear me talking with my mouth full. Take a drink. I can't imagine many people are watching tonight because it's the Saturday night right before Halloween, since Halloween's on a Monday, so no worries. I actually don't, in case you're curious, I never watch how many people are actually watching. And it's partially because I just don't know how. I literally like have never tried to figure out how many people are watching. Like sometimes on LinkedIn I can see like if there's one or I can see that there is one or two people watching, but I don't know who they are. So if you're watching, welcome. Drop a comment or something. Say hi. Anyway. But of course you can always watch these on repeat or replay later. Okay. So the one thing I do want to note here is you might be wondering what pluribus means in this context. So the best way I can describe it is like think of M&Ms versus like a candy bar. So like M&Ms or Whoppers or anything. So basically like you have all these little chunks of things that are in a box as opposed to like a full like candy bar. So a pluribus positive candy would be M&Ms. Pluribus negative candy would be like Snickers. So that's the only thing you need to be aware of. Okay, so the first thing I want to do before we jump into visualizations is I want to show you how to create a theme around the visualization, like in terms of the colors. And so it's actually really easy to apply a theme with Seaborn. I guess I should take a step back. So Seaborn and Matplotlib, these are two libraries that work very well with one another. So whereas Matplotlib is like the bare bones kind of visualization thing. So like Seaborn kind of sits on top of it and then helps to like prettify it and make Matplotlib a little bit easier to work with. So we will be using the two interchangeably together because you can actually use Seaborn, and then if you really need to tweak some stuff under the hood, then you can use Matplotlib. So that's why we are going to be using both of them directly. But anyway, as far as creating a theme around your visualizations, we are going to add some color theming. And so the way that we can, Seaborn allows us to do that pretty easily. So with hex value. So some of you may know that on the side, I like to dabble a little bit in graphic design. And with that, like the way that graphic designers work is that when we need to hone in on a very specific color value, we use a hex value. So you might be familiar with hexadecimal. So this is the same concept. It's just applying the hex value of a color to I just said it. So it's basically applying a hex value to a specific color that you want to hone in on. And so there are actually a number of different websites that will actually curate like 4 or 5 different colors together that look sort of aesthetically pleasing. So that way you can have a color palette, that looks nice. So I personally used this website right here. And so you can see this is the color palette that I'm going to be using. I'm going to change the order of the colors though. So you can see that, we got a pumpkin orange, a nice pumpkin green, purple, like a witch kind of purple here. And so here are the hex values up here. And then I guess there are RGB values. I personally prefer to use the hex values because I find them a little bit easy to work with. So I've already copied these down. So I'm just, instead of hand typing them. So what we are going to do here, and you don't necessarily need to do it this way, but I just think it's the easiest way to do it, is I'm going to create a little bit of a dictionary here with all these different hex values. So I'm just going to copy this here. So Halloween colors, I'm going to paste this, copy and paste. Okay, so here's our Halloween color. Same thing that we just saw here in the other screen over there. So we got orange is this FF9A00. So this is our Halloween colors dictionary. Now, in order to actually set the color palette, it's actually pretty easy. So with Seaborn, all we have to do is call this function called setPalette. And oops, sorry about that. And pass in our Halloween color. So sb.setPalette. And then sp.color palette. All right, so we're going to provide a color palette. And then we are going to provide, we're going to basically turn our because it doesn't need these other colors. The reason I use this, I'm actually gonna not probably use this dictionary in the rest of the stream, but if you follow the blog post, or if you look at the actual Jupyter Notebook that I house everything on with over on GitHub, you can see that I actually do use these colors to refer to specific things in specific scenarios, but I actually only just need these values. So what I'm basically going to do is just grab the values from this dictionary. So I'm going to do list Halloween colors dot values. Okay, so all right, so that is how we set the colors. Now, the other thing I want to do is I want to give a little bit of a dark background to our Seaborn visualization. So I just want to show you really quick. So Seaborn set style. Okay, so just so you're aware. Okay, so Seaborn, when we set the style, there's actually a number of different values that we can pass in. So we can pass in dark grid, white grid, dark, white, and ticks. So this is like the white light grid. This down here is technically the dark grid. So it's not super dark, but it's just a little bit darker. But again, this is Halloween special theming, so we are going to choose that dark grid. So the way we do that here is we're going to do this sb.setStyle, and then we're going to do the dark grid. There we go. All right, so that is really setting up our colors here. So that is, so whenever we start to create our visualizations, Seaborn, because we've already set these colors behind the scenes, it's going to automatically pull those in. So anytime we use our creator visualizations, it's going to start with orange, and then if it needs multiple colors, then it's going to go in purple, green, and so on and so forth. Now I'm going to keep this relatively simple for some of these first couple visualization or so, but then we'll gradually get more complex. So the first one I want to show is the count plot. So a count plot is basically a bar chart. So like basically, if you imagine, we're counting, well, let's say we open a bag of M&Ms and we were just curious the number of different colors of the M&Ms. So we would just say, okay, I got 6 blue, 3 yellow, 2 brown, and 5 red, or something like that. And so then we just have these bar charts. So the 6 blue, the 3 yellow, the 2 red, or whatever I just said. So I'll show you how to do that really quick with Seaborn. So what we're going to do is we're going to just apply this to just our chocolate column. And then we're just going to do a very simple count that way. So the way that we do this is we are going to use Seaborn, and we're going to create a count plot. So count plot equals the sb.countplot. Okay. Now we are going to pass in our data frame. So we're going to set the x value. So we're going to set the x value to be df candy, and then our x value is going to be chocolate, because this is what we're going to view. Now, so that is really the one thing I should note before we move on is, well, I'll just go ahead. I'll just go ahead and run it. So here is our very simple visualization. Now, by default, you can see that it is pretty simple. It did inherit our colors. Notice that it just set the what would we call this? The Y limit to be 50. So it sets the Y limit by default, but you can go on above and beyond to adjust this thing to have as much or as little as you want to it. So we could add a legend. We could change these values down here. Or we could change like a bunch of different things. So, for example, like, I guess it's surprising it didn't show this up, but usually if you don't put like, this is the kind of the one weird thing about visualizations in like Seaborn is sometimes it'll show like this weird like hex, like count plot dot blah, 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 and then like some sort of hash value here. And the only way to suppress that is by adding a semicolon after that. Now that's kind of counterintuitive because in Python we don't typically use semicolons, but just for your awareness, if you do go through my Jupyter Notebook and you notice I use a bunch of semicolons, that is the case. I'm trying to suppress that thing out, and I don't know, maybe it's not showing up here because I'm using a different theme. Jupyter Notebook thing, I'm not sure. So, but you could see it when I add the semicolon and I run it again, nothing really changes. So now let's say I want to add a title on this, and the way to do that is doing so we're actually going to just use well, I can't remember how to do this necessarily. So is it count plot dot title, count plot dot title, and then let's see, number of chocolate candies. Okay. All right, text is not a callable. Okay, so I don't recall how to do this off the top of my head. Hold on just a second. I'm just looking at my notes here because I did it a different way. So I can't exactly remember 100% sure what I did because I did some funky things when I did this for like this notebook. Okay, so I'm actually just going to use the straight Matplotlib here. So we imported it as PLT if you recall. So I'm going to do plt.title. And then I'm just going to add a title to this. So counting the number of chocolate candies. Boom. All right, there we go. So now we have a title. And you can do a lot of different things to make these visualizations really fancy. So if I want to make the font a little bit bigger, I think it's font size. Font size equals 36. Let's just make it really big just to highlight the fact that, yeah, there we go. So it is super big now. I typically like to go about 18. Even that's a little bit big for my liking. 16. So I'm just gonna adjust that like so. So that is how you add a basic title. So we're just keeping things simple right now. We can the thing about Matplotlib and Seaborn is that it can get very powerful very quickly. And so you will be able to see if you go into my Jupyter notebook or read the blog post. It gets very complex very quickly. So we're just starting off slow now because I just want to show you some basic things that you can do, and then we're going to do a few more advanced things. So you can see here just by our visualization, so you can see that there was in this data set. So I guess that is something that we should have looked at here. Oh, I guess you could see here, this is kind of what I was talking about before, where if you don't add the semicolon, then it starts to add this weird text stuff here. So again, if you want to suppress that, just add the semicolon. Again, it's a little bit counterintuitive given that, in Python, we don't typically use the semicolon for anything, whereas, Java might. So yeah, I guess coming back up to here, so let's look at length of dfcandy, or dfcandy.info. How about that? Candy.info. Okay, so you can see here, this is actually a relatively small data set. So there's only 85 entries here. And so you can see here that it's not super clear, but you can see that there's basically a 85 split here. So what is this? Probably about 48 or so, and this is maybe 37. So a few more non-chocolate candies than chocolate candies. But the reason we create these data visualizations, and this one's relatively simple, but we're going to do one that's more complex, and it really, these visualizations help to tell a story. Now, the thing that I want to be careful about is that you can really tell a fake kind of story. So especially where people really deceive other people the best is by like fudging around with this like the y-axis here. So let me show you how to do that. So I'm gonna go and say, all right, so I want to change the y limit. So right now it's defaulting to 50. And I just want to show you what happens if we change that. So the way that we're going to do that is we're going to do, so we've already created this count plot object. So we're going to do count plot set ylim, and then it's going to take two values. So the first value is going to be the bottom, and then the second value is going to be the top. So I'm going to actually intentionally set it to start at 30 and end at 50. So I'm going to go 30, 50, and let's watch what happens here. Okay, so now this is really, well, I guess I should have done the two side by side, but well, yeah, I do want to do that. So hold on. Okay, well, not really side by side, but I'm just gonna copy and paste the same code, put it down here. Okay, so you can see here that whereas it appears to be fairly level here. Now when we come up to here, it looks like there's a much wider gap than there actually is. And so this is the thing that we need to be very careful about whenever we're creating data visualizations. People will intentionally do this to tell a certain story. This is a kind of a deceiving story. So I got to be careful here because I don't want, well, never mind. I was going to point out an illustration of a certain company that likes to create weird little graphs like this, but I think that would not be a good choice. But yeah, you can see here, whenever you start to fudge around with these kind of things, now we're telling a different story. Now, whereas it looked like we have like not that big of a gap, now the gap looks way bigger, but the data's not changed. It's just that we changed this y-axis. So we need to be very careful about that. So, but I mean, the one thing that I want to take away here, though, is how easy it really is to create these visualizations with Matplotlib and Seaborn, and how intuitive they can be. So we just created a very simple count plot here. Now, that was just for one of our binary variables. What if we wanted to do this for all 9 of them at once? So what I'm going to do here is I'm going to actually, because I mentioned there were 9 variables, so I'm going to create a new data frame here. I'm going to call this df binary to represent all of our binary variables. And I'm going to pull out just the variables that have an integer value, just because I know that those are the ones that that have the binary values in them. So df candy select d types equals int. So just to show you what this looks like, df binary is now just the 9 columns of the binary values. And now the next thing I'm going to do is I'm going to change all these zeros and ones to be yeses and nos. So the way that we do that is going df binary.mask. So mask is like doing a check to, like a conditional check to see if you meet the condition, then keep it a value. If it doesn't, then don't do anything. Now the one funky thing is Pandas has 2 different functions. One is mask, and I can't remember what the other was called, but basically they're inverse of each other. So one is if you do meet the condition, then change the value. And then the other one is if you don't meet the condition, then do something else, which is kind of funky. Like, I don't know why they're not the same. I don't remember what the other one is called off the top of my head, so I apologize for that. Oh my gosh, I can already feel my voice going. So let's keep going. So if df binary, if it equals 0, then we're going to change this to no, and then I'm going to do in place equals true, and then I'm going to do the inverse of that, basically the same thing though. Df binary dot mask, well, not really the inverse. Df binary equals, if it equals 1, we're going to change it to yes. In place equals true. All right, now let's look at this again. Df binary. Now everything shows up as yeses or nos. So now what I want to show you to do is how to create a grid of different visualizations. And so the way that we do that is we're actually going to use the underlying matplotlib to create some subplots, and then we're going to create all these different count plots as one giant thing. So the first thing that we need to do is we need to create the actual subplots. We're going to call this figure, axes equals plt.subplots. All right, and then we're going to call it, I want a 3x3 grid, and I'm going to do a fig size equals 14x14. Now, there is 3x3 makes sense because we have 9 different variables, so we want 3 rows and 3 columns to make basically like a Rubik's Cube kind of square kind of thing. The fig size, this is really up to you. I think the only reason I settled on these numbers is because I just played around with the visualizations a bunch. So this is the thing that you'll notice whenever you actually do your own work, is when you start to create a visualization, like you'll do a very basic one just like this, and then you'll start to adjust it appropriately. So you can see here that we never did actually change the X label on here or the Y label on here. We just kept it same, and so you can see it says 0, 1. And the reason I changed it from 0, 1 to yes or no here is because I could not figure out how to change these values down here, and so I just decided, well, shoot, I'll just change them all up here. Doesn't really matter because it's going to show up the same anyway. So all right, so we created the figures and axes. Now, in order to, I'm going to create a for loop, and so what this for loop is going to do is basically is going to iterate through all of these columns and then create the visualization appropriately. So what we're going to do is whenever we actually create the visualization and with count plot is we are going to set a basically 2 coordinates, that like an X and a Y coordinate that says, okay, now for our first visualization, do it here, and then 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 here, and here. And so what we actually need to do in order to do that is we need to instantiate some values representing our X and Y coordinates. So X coord, Y coord equals 0, 0. So we're just doing a quick, so if you're not familiar with the syntax, this is actually, it's not super common. I personally don't like to use this syntax unless it's something super basic like this, but basically it's saying, okay, I want this X coord to equal 0, and I want this Y coord to also equal 0. So, and that's just like a shorthand of how to do this in Python. So now let's go ahead and iterate through all of our features. So for feature in df binary.columns. So this is just iterating through each of just to show you. So print feature So it's just iterating through all these different features. So so I guess this is something nice that you could see. So by already just doing this here, you could see our 3x3 grid. So we've already seen how we create these different visualizations as such. So this is just one big thing where all of our count plots are going to be visualized. So all right, so for each of these features, now we're going to do the count plot. Count plot equals sb.countplot. All right, and so basically we're doing the same thing that we did above. So df binary, this time we're just going to pass in the generic feature. Order. Now I do want to set the order. Order equals, so we could have done this above, but we do have, now that we have these yes or no values, I want to make sure that they're always in the same order, because the thing I noticed is there was actually one variable that there was more yeses than nos. So a little bit of a spoiler alert, there's actually a lot more nos for most of these variables than there are yeses. So I'm gonna go ahead, and for some reason it defaults to the first, to showing the one that has more first. So like the orange bar on the left might be yes sometimes. So in order to fix that, and so where it's always the same order every time, we can actually dictate that with a tiny bit of array here. So order is yes, no, or yes. All right, how am I doing? I need to go blow out that candle. It's starting to get smoky in here. Okay, sorry about that. I just turned around and I was like, oh no, I hope that fire alarm doesn't go off. All right. So, all right, setting that. Now, the one other thing I do want to set here is the axes. So, like I said, we are going to, we instantiated our figure, our holistic figure, and our axes here. So we are actually going to put this particular visualization on the x coordinate and the y coordinate value. Y coordinate. Okay. Now, I do want to set the limits just so everything is a little bit. Now, this is the other thing where people can lie about their data. So we're doing 9 different count plots here. By default, Seaborn is just going to pick the one that the limit that it feels is most appropriate. However, as you can imagine, like let's say, one limit is 50, one limit is 80. Now we're starting to misrepresent the data. So we want to be very consistent with how we're visualizing the data. So we are going to set this consistently. So countplot.set ylim. We're going to set it to 80. So 0 to 80 for every single time. Now, I do want to set the X and Y labels this time. So the way that we do that, pretty simple. Countplot dot set Y label. Oops. So I'm going to call the Y label counts. And I'm going to set the font size here. Font size, I don't want to go too big. 12. Countplot dot set X label is, we're just going to call this the feature name. And again, we're going to do font size equals 12. And now, so that's basically it for actually visualizing this thing. Now, as the loop goes through, we do need to increment the values of these coordinate positions appropriately so that we're not constantly overwriting the same values. By the way, that is not smoke. That is actually just my humidifier now. So fun fact, because I've been sick all week, I've pretty much lived under this humidifier, and so I've always had this smoky look. And I have spent so much time under this humidifier this week that literally I've just been walking around the house when there has not been a humidifier and seeing smoke. So that's kind of freaky. So like that I'm seeing smoke all the time. All right. So anyway, what we want to do is, so we're going to increment the X coordinate first, X by 1. And if it approaches 3, remember, because we're doing a 3x3, then we need to reset the X coordinate and then increment the Y coordinate. So if X coord equals 3, then we're going to do Y coord. We're going to increment that. Y coord plus equals 1. And then X coord, we're going to set back to 0 as so. All right, now we could add some more on here. We could do things like, adding a title and things like that. I'm already spending way too much time on this one visualization here, but I do want to show you what happens when we actually run this. So now that we've run this, you can see that we get all 9 of our visualizations all in one fell swoop here. So and now we're starting to see an interesting story here. Well, I guess I should say it's not super interesting, but like you can see how something like this may be super helpful to somebody who's like creating a new predictive model. So you can see that, we got our chocolate column. So chocolate is pretty evenly divided. But then we have things like nougat. Now you can see hardly any nougat candies. And again, this is just a fun data set that I picked out. Like, this is like in the real world, you might glean some like better insights here, because you might be thinking, well, of course, not many candies are actually nougat candies. And you'll notice that most of these variables in here are no. Now the one the one on here that is an exception is this one down here at the bottom, and that is why actually I set this order yes or no. And in fact, let me just go ahead and show you what happens if I take this out. So you can see here everything actually, yeah. So you can see how these things are ordered a little bit differently. So sometimes the yes comes up first, sometimes the no shows up first, and that can be a little bit confusing, because if you're reading this too quickly, you'll just look at the orange one and say, oh, those must all be like the no first. So that's why we, again, you do want to be careful while you represent your data, and so that's why I did set the order very specifically like so. So let me go ahead and rerun that, and so you can see here that everything here most of the time. No does outweigh the yes. However, the one exception to that is this pluribus down here, and that kind of does make sense. So if you think about, again, pluribus candy would be like M&Ms, Whoppers, I guess Nerds technically, things like that. I wonder if Nerds is even on here. I'm curious. DF candy, DF candy, competitor name equals Nerds. I wonder if it's capitalized Nerds. Maybe Nerds is on. Oh, Nerds is on here. So you can see. Oh, yeah, there we go. So Nerds are very high in sugar. I wonder if Pixie Sticks are on here. I actually did not look super close at this data set. So yeah, you could see how it's very easy to create these visualizations, and they could tell a very interesting story. So again, like I said, this is all. If you knew nothing about candy, you might be surprised. Why are there so few nougat candies? And it's like, well, nougat's good and all, but like, I like a variety of things. So that's those are count plots. Now, let's keep moving along. My voice is already starting to give out. So there is again, there's a bunch of other different visualizations that I did cover in the blog post. But I want to show you another really, really fun one, because that one's a more basic one. So, or maybe we'll show a couple other ones. So, let me think. Yeah, I want to show this one here. So another interesting one that I want to show is like, let's say you are comparing two variables. And then you want to see how do they necessarily correlate to one another. And so what we're going to be comparing here is the sugar to price. So are the more sugary candies greater in price if they have more sugar? Like, all right, hold on. I'm sorry, tripping over my words here. Are the candies that are more sugary, do they tend to be higher in price? And then if you want to add an additional question on top of that, the additional question you might be wondering is, how does that compare necessarily between chocolate and non-chocolate candies? So the way that we're going to do that, and we can jam a bunch of different information into one single, very easy to read visualization. So what we're going to be doing here is creating a regression plot. And so specifically, Seaborn has this functionality called LM plot. Now, to be transparent, I don't know what LM stands for, but we're going to be using this and to actually visualize this candy here. So the way we're going to do that here is we're going to do regression plot equals sp.lm plot. And the reason I want to show this is partially because it's super informative, and I actually think this is one of the more fun visualizations that I created. So first thing, data we're going to pass in is df candy. So that is our pandas data frame. I mentioned that we are going to pass in as the x value the sugar percent. The y value here, we're going to pass in as the price percent. And I'm curious if this will just run if I don't add anything else. Okay, so you can see here that we this is just the very basic visualization. We did not add, because I mentioned we do want to add the chocolate candy on top of this. So this is just showing in general. These are all of our 85 data points. And so what this is basically showing here is a correlation between the values here. So you can see that there's not, and what this line here is representing is the regression line. So this is actually showing us, okay, how much of a correlation are there between these two values. And so you can see there is a tiny bit of a correlation, but not much. If there was a very strong correlation, it would be, something that started down here and then work all the way up. Or if there was a negative correlations, we'd see a negative slope. So this is, back to your high school days and working with the Cartesian plane, you might recall that, the y equals mx plus b formula. So the slope here is gentle and positive. So this is like I don't know, so if you think about rise or overrun, this might be like a 3/1 or something like that. That's probably a gross misrepresentation here. But basically, what this is basically showing us here is there is a gentle correlation here. So that is how to create a very. So this is actually combining a scatter plot with with the regression line here. But the reason I like to use this element plot is because you can do some really fun things with that. So the one thing now, so this is just comparing the. Here I'm going to add a height here. Height equals 7. So just to make it a little bit taller here. So now so we can see things a little bit more easily. Okay, so now let's say we wanted to look at this between chocolate and non-chocolate candy. So the way that we do that here is by adding what is called a hue to the visualization. And so what we're going to do here is we're going to pass in this hue of chocolate. And then we can actually change so right now by default, our visualization is using little circles to represent our data points. And the interesting thing is we can actually use a number of different what are called markers to represent the data points. So you could have circles to represent one and X's to represent the other. So that's what I'm actually going to do here. So I'm going to pass in another variable here, or another parameter here called markers. And it's just going to be a little list. And so the first one we're going to call X's. And then the second one we're going to call O's. All right, so now this is where things get really, really interesting in my opinion. So let's just go ahead and run this and show you really quick. Now this is showing a lot more information than before. So again, the orange candies are represented, the non-chocolate candies are represented by the orange X's. So you can see all the different individual data points here. Whereas the purple is representing the chocolate candies. And so now you can see that we're getting a different story here. So between the chocolate and the non-chocolate candy, so let's just look at the non-chocolate candy. So you can see a lot of data points around, not high in sugar, which is kind of weird to think about, because when I think about like sugary candies, I think about like pixie sticks or whatever, just like the most artificial things on the planet. Excuse me, I'm gonna take a quick drink. But there is a very gentle correlation. So I would not call this a strong correlation at all. And by the way, again, I should have used a different data set, but this is the only I really wanted to do a Halloween theme, and this was the only one that I could find. I'm still extremely grateful to 538 for this data set. But this is probably, not representative of like all the candies in the world. Although I guess to be fair to them, like, 85 candies is quite a few candy brands. Yeah, so anyway, so you can see a very general correlation. Now, the thing that's interesting when you compare these two is there is a consistent higher correlation of chocolate candies when it comes to both price and sugar. Now, that is a little bit surprising to me. It's actually not surprising me with price. So, like, actually, my daughters and I, we just walked, we were at Target just earlier today. And we walk down the candy aisles, and it's always that, the chocolate candies are higher, like the big bags of the chocolate candies are higher in price than the sugary ones. So, yeah, so that actually doesn't surprise me. But you can see here that we start to get more data points up here. So with like the sugar percentile, so we actually have, there are quite a few of these orange candies that have a higher sugar percentile. But yeah, you could see, so we're getting a lot of different information just from this one visualization here. So we are seeing the correlation between price and percent. We are seeing how this compares between chocolate and non-chocolate. We are seeing a difference between the chocolate and non-chocolate. We are seeing a gentler correlation for non-chocolate candies and a stronger correlation for chocolate candies. Now, does this tell us anything? I don't know. Again, this is a very small data set. Whenever you're actually working with your real data set, let's say we're working with hundreds of thousands of different data points, this could tell a significant story. This could tell us everything in the world. So this is why we create a number of different visualizations, and we tried different things out here. And my humidifier is just going real crazy right now. That's not actually smoke. Like, but I'm really happy with how the aesthetic of the stream is turning out, with my sea captain's hat and everything, and the candle before I had to blow it out. But yeah. So anyway, so that's how we can create a really interesting kind of thing like this. So that is another one of these. Now, for the last section here, I want to show. Well, actually, no, I do want to show. What time do we got here? Okay, I do want to show, well, a couple more visualizations. So we just showed that joint plot. Now I want to show another different kind of, I'm sorry, that was an LM plot. I want to show another kind of correlation plot that you can create that's going to give another different kind of look into our data. So what we're going to do here is, this is called a joint plot. And a joint plot you can actually do a number of different things with, but it's basically saying, okay, I want to do a correlation between two different variables, and I want to view it differently. So before we did a sugar to price, now I want to do a price to win percentile. And so we are going to be creating a joint map. And what the joint map is going to do is it's going to visualize the data and what looks almost like a topographical map. And then it'll tell us, and then on the outer side of the X and Y axes, they're going to show what is known as the KDE curve. So KDE standing for kernel density estimate curve. So that is just going to basically show, okay, we think that more often than not, the data is actually clustered in this general vicinity. So that, what I'm basically saying verbally probably doesn't make much sense, but let's go ahead and visualize it for you. So I'm going to be using Seaborn's joint plot for this. So joint plot equals sb.jointplot. Okay, so we're going to pass in, as the X variable here, we're going to pass in df candy. And like I said, we're going to be comparing price percent, or price to win this time. So I'm going to do price percent, and then the Y value is going to be the same. I'm going to just copy this here. Is it highlighting? I can't really tell because I have so much of this like mist here that I can't see with this dark theme if things are actually getting highlighted or not. It's kind of funny. All right, so Y equals df candy. Candy. Win percent. Now the interesting thing about these joint plots is you can actually, I do want to do a hue this time, so I'm sorry. df candy chocolate. The interesting about these joint plots is that you can actually create them in a variety of different manners. So like I mentioned, we are going to be using the kernel density estimate to view things as almost like a topographical map, because I think it's a very interesting kind of visualization. But just know that you can actually do it. Well, let me just go ahead and look this up. So Seaborn, where's joint plot? Joint plot. There it is. So joint plot. Now I'm gonna be giving away a little bit, so you can see here that this is like showing the histogram on the X and Y axis. So it's pretty cool how you can visualize different things here. So I don't want to scroll down too far because I'm afraid then I'll give away the visualization here. But yeah, so you can do a lot of different things with these joint plots. So let's come back to our notebook here. So I'm going to create a KDE. So kind equals KDE visualization. I'm going to set the height to equal 7. So height equals 7. Okay. All right. So let's go ahead and run that. Now you can see this is kind of cool. Like I thought when I first generated this visualization, I thought this was really awesome. But basically, what you could see here is we can really now I forgot that like the data set by default does not change. Like for some reason the price and sugar percents are between 0 and 1, but the win percents are between 0 and 100. So I forgot to like scale them down, but it doesn't necessarily matter too much for this particular visualization. But you can see here, so now we get to see our chocolate and non-chocolate candies, and I did not change this legend to purpley, although I could have. But basically, so when we see the chocolate candies here, we can see that there's the strongest correlation is where the price is at about this 68th percentile, maybe a little bit higher, and then and the win percentile is somewhere around the 70th percentile. So you can see that's the nice thing about this particular visualization is if you really want to hone in to see where is the most specific like the correlation between the data, we can very clearly see it here. And then as we go out, we can see it start to get a little bit looser and stuff. So this is a really cool kind of visualization. And then on the orange one, so this is the non-chocolate candies, so you can see that there's generally there is a correlation, but it is toward the lower ends of these values. So you can see that, the middle probably here is around what is this, like the 25th percentile, and then for price, and then on the win side it's like the 41st percentile. So you can see, at least, so, and this is the other cool thing is that it's actually visualizing the distribution of the values on either side of the with these curves on either side of the axis. So you can see here with the win percentile, well, actually it's probably easier to look at that with the price percentiles. So with the price, you can see that the chocolate candies tend to hang out around this little over halfway point, whereas the non-chocolate candies are on the other side. Now this is on the flip side, unfortunately, like, this is a little bit more difficult to see now, just because, keep in mind, so it's easier to read left to right. So it's, if you turn your head to the side, it almost looks like, well, why are the chocolate candies winning less? They're actually not. It's just that this is actually higher up on the curve. So you can see that, the chocolate candies did have a little bit of a higher distribution of wins, which doesn't surprise me. I feel like people like chocolate candy in general more than non-chocolate candy, whereas the non-chocolate candy is on the lesser side of things. So this, again, showing a lot of different information out of one visualization. And again, we could have changed this from KDE to, well, what else could we have done? So kind. So yeah, you can see scatter, hist, reg. So let's look at hist out of curiosity. I actually have never tried this. I'm not 100% sure it's going to run, but we'll try it out anyway. Hist. Yeah, this is why I don't do things on the fly, because I don't know exactly what we're looking at here. I guess we can. Well, I guess it's trying to represent, like, the darker colors are where those correlations are at. Although this is kind of hard to read. That's why you got to be careful about what you choose. So what was there? There was hist. Hist scatter. Let's just look at scatter and see what that looks like. Scatter. Okay, so this is a little bit more basic. So this is a basic scatter plot, very much similar to the one that we see above. Although, again, keep in mind that this is sugar to price, whereas this is price to win. So you can see a similar KDE curve appear on either side of the axes, representing each of these variables here, and then the actual correlations are represented here. So depending on how you want to visualize things or what makes the most sense to you, you may choose one over the other. So I'm going to go back to KDE. I just thought this was really cool looking, like when you think about like a topographical map and what these things look like. So fun stuff. All right, so now let's go ahead and start to move into our final visualization here. So with the final visualization that I want to do here is I want to do a little bit of clustering here. So what we're actually going to be doing is we're going to be instantiating, or we're going to be doing a little bit of k-means clustering, some very basic k-means clustering. So I'm going to need to import some more or additional libraries here. So the libraries that I'm going to be importing are from scikit-learn. So I'm going to put from sklearn.cluster import k-means, and then from sklearn.preprocessing import standard scalar, because we want to scale the data before we scalar. Before we actually import it. So what we're going to do is we're going to create two different visualizations here. We're going to create, we're going to do two different rounds of clustering. So in the first clustering, we are actually going to be having the k-means cluster divide the candy into two different clusters, and then we are going to go, do it again, except this time with three different clusters. Okay, so the way we are going to do this is first, we need to first scale the data appropriately. So let's instantiate a scalar. So scalar equals standard scalar. Okay. And then I'm going to create, or I'm going to extract the data frame with, because I need to scale the data, except we have the one field name that's called competitor name, which is just like the list of the candy. So we need to drop that. So I'm going to call this df equals df candy dot drop columns equals competitor name. Okay, so all right, so basically the same data frame that we started off with before, except now there is no first one. So now let's go ahead and scale our data. So scaled data equals scale. Oops, I'm sorry about that. Scaled data equals scalar dot fit transform df, and then I'm gonna pop it back into a scale frame or a data frame. So df scaled equals pd dot data frame. Data equals scaled data, and then columns are going to be equal to df dot columns. All right, so let's just look at this really quick. So df scaled. All right, so this is all of our data that is appropriately scaled using the standard scaler. Okay, so now what we are going to do is we're going to take the scaled data and we are going to create the clusters appropriately. So I'm going to create two different k-means clustering algorithms, and I'm going to fit the data to them appropriately. So I'm going to call this one k-means 2 clusters. Clusters equals k-means number of clusters equals 2 dot fit df scaled, and then I'm going to do the same thing, because I'm going to do this for 3 clusters. So 3 okay. All right, so we just fit the data to them. Now we are going to create this new column on our original data frame that is going to represent each of these clusters appropriately. So I'm going to call this df candy 2 clusters equals k-means. All right, 2 clusters dot predict df scaled, and then basically the same thing here for the 3. I'm going to change this 3. All right, so now let's look at this df candy. Okay, so now if we come over to our leftmost column, you can see that we have our clusters here. So our clusters are starting at the index value of 0. So obviously the 2 cluster ones only have 0s and 1s, and whereas the 3 cluster ones have 0, 1, and 2. Now, what we're going to do here is we're going to create a scatter plot, but this time, because we really are, I want to get an intuition of how is the data actually being clustered. What we're going to do is we're going to put the label of each candy on top of each data point. So that way on the actual visualization itself, we will be able to see all that. So this is going to be a little bit complex, so just stay with me. I think you'll be able to see this just fine. So I'm going to put the number of, I'm going to create a little thing called num clusters here. So it's just a little array that we're going to just do a for loop through. So that is 2 clusters, 3 clusters. Now, so we are going to create a figure and axes again. So just like we did kind of above. So figure axes equals plt dot subplots. So we only have 2 of them this time. So we want to do a 2 by 1. So 1 up and then 1 down. So 2, comma 1, and then the fig size equals. I just did a 12 by 12 here. By the way, full transparency, I am just reading off the same code that I wrote like last week for the blog post, which is kind of good that I'm doing it not super live this time, because like I'm still a little bit sick. So I'm surprised I'm able to hold on this long. So all right, so you know, because we don't have a 3 by 3 grid as we did above, we only need to do a y coordinate value this time. So y coord equals 0, and now let's go ahead and iterate the thing. So for cluster in num clusters. Oh my gosh, can't type. All right, so for cluster and num clusters, we are going to create a scatter plot. Scatter plot, sp.scatter plot. So we're going to pass in our data equals df candy. And oh, I guess I should have said we're going to be doing another comparison between the win and price percent. So the x is going to be the win percent. Y is going to be the price percent. Okay. Hue is going to be the cluster. X is going to be the X. So we're going to put this on the Y coord. And then actually, what did I do here? Oh, I actually, for some reason, the colors didn't want to take appropriately, so you can actually set the colors manually. So I'm just reading my code here. So I'm actually gonna set the color palette very specifically here, because for some reason it didn't take like I wanted it to, like the first like it typically does. So I'm just gonna pass these in. So list Halloween colors dot value values. Okay. All right, now so that's actually just creating the color, the plot itself. Now, if we actually want to put the labels on everything, this is where things get interesting. So what we need to do is we need to go through every single one of these columns here. So basically the competitor names that we are seeing off on the left right here, and we want to basically throw them on top of each visualization. So the way that we do that is we're going to iterate through them. So for I, comma candy, in enumerate list df candy competitor name. So this is again just iterating through all the different candies that are in here. What we're going to do is just add a little text block on top of it. So we're going to do scatter plot dot text. All right, so x equals df candy. So we're basically saying, okay, put a text label at this x coordinate and this y coordinate, and this is what we want it to say. So x equals df candy win percent, and then I, because we're trying to, and then we're gonna just shift it up into the right just a hair. So the way that we do that was we're gonna add just a little bit of a nudge, so a 0.02 nudge. So that's the x. Now the y, we need to do the same thing. So df candy, okay, price percent I plus 0.02. All right, so the label that we want to pass is, so S, that's the string. So we're going to pass in the name of the candy. So again, because we're iterating through everything here, so we're going to pass in the candy. And then finally, the one last thing we need to do is we need to make the font super small, because we're adding 85 data points to this thing. So we need to make sure that the font is as small as we can get it. Well, actually not super small. You can actually go extra small. So font size equals X small. You can actually do a double X small, but I found that to be a little bit too tiny. And then I need to increase. All right, so that's it. I just need to increase the y coordinate. Y coord plus equals 1. Now again, we could add different labels and stuff, like changing the X label and the Y label of everything, but I just want to show you how cool this visualization is. All right, so now we have our two different visualizations here. So the one up at the top, this is our 2-cluster visualization, whereas this one here on the bottom is our 3-cluster visualization. Now you can see when you compare these two that they're mostly the same, and I don't know why the colors necessarily got out of order here, so you can see that basically the purple here and the orange here are the same. Let's just look at the top one first real quick, just to see how it may, like, again, we did not really look at the data after clustering. We're just looking at purely after we have visualized it after the fact. So let's just look at a couple here. So we know in the purple cluster here we have Boston baked beans, chiclets, Super Bubble, Nick Elnip. By the way, so this one's funny. So like you'll notice that Nick and Elnip like was by far like the biggest loser in terms of win percent, but it's like the highest price. I did not know what this was. I had to Google it. So what these are is actually those little like wax bottles that you can get that like you can like bite the top off of and like get the little sugary goo out of it, and like, oh, those things are nasty. I'm sorry if you like those, but anyway, so that's all those candies. There's some Werthers, and now let's look at this other cluster. So you can see like we got Snickers Crisper, Three Musketeers, Kit Kat. So basically, what I'm seeing here is basically this is what the K-means clustering did is separated chocolate versus non-chocolate. So I mean, that's fair, because I know it did the K-means clustering algorithm did not just look at just the chocolate value, but when you think about a chocolate candy, it has things like nougat, caramel, some of the other features associated to it. So like the nougat and the caramel are always going to be associated with these chocolate candies, whereas opposed to these sugar candies, they're not going to necessarily feature those. So now let's compare that to our 3-cluster visualization here. So again, everything's basically the same. Sorry that the colors got kind of flip-flopped here. So first cluster, we see a lot of the same ones in here. The second cluster with the purple, a lot of the same ones. And then we start to see a little bit of a different one with the green colors here. And this is actually kind of interesting because I don't know what I did differently, but I got some different results between this time and the last time. That's very curious. Does K-means have like a random seed associated to it? I guess I've never looked it up, because when I did this with the blog post, it was actually showing like Snickers Crisper and Kit Kat as their own group, and now it's showing like Payday and I don't know what this one is here, but Milky Way Midnight. So let's just analyze these on its surface. So Baby Ruth, Three Musketeers, Milky Way, Payday. So I see a little bit of a correlation here. So in my blog post, you'll notice that the actual visualization showed up things like the Snickers Crisper. It was basically like all the crispy candy bars, and there is a little bit of a correlation here. So they're all different. They're definitely all candy bars. They're all chocolate covered candy bars. Three Musketeers are a little bit more nougaty, but like Three Musketeers and Milky Way Midnight are pretty close. Now, Baby Ruth and Payday are also a little bit close in the sense that they have, they're also candy bars that have like, correct me if I'm wrong, they're like peanutty, right? Like, I'm honestly not a big, I like Baby Ruth and Payday, don't get me wrong, they're just not my first choice. So I can't recall what those are like off the top of my head. And then I can't really see what the text is showing on top of here for this other one here. But yeah, let me go ahead and just show you the blog post really quick, because the blog post is actually, well, or not just the blog post, but I guess I could show you just my Jupyter notebook. Where is my GitHub? Okay, so by the way, this whole thing is visualized in this notebook here in GitHub. So this, and usually with these live coding streams, you all know that I'm very good about annotating things. I purposely did not, because in this one, because I like, in this notebook here, you'll see that like this notebook is actually like 10 times cleaner than the one that we're looking at right now. And it's got all the annotations and everything. So if you come down here and I look at this, this is the same code that I just ran, but it's curious how, okay, so you can see here, or maybe it did. Maybe I'm just being silly and misremembering things. But yeah, the third cluster, well, I guess it did. So if you look at the third cluster, like as opposed to the second cluster, like you could see Snickers Crisper and all the, or Butterfinger and Twix and all these. So like all these ones that are a little bit more crispy, crunchy kind of candy bars all got looped together. Whereas you love like Three Musketeers and Milky Way that are a little bit more nougaty or a little bit more peanutty. And I unfortunately I can't read what that one is. Well, I guess we could if we come back to the notebook. Let's see if let's change this to XX small. So XX small. It's going to be very small, but we should be able to read these a little bit better, or not. Well, that kind of backfired on me. But yeah, so you can see that with these visualizations like this, we can glean a lot of different information about the data here, and we can visualize all these different things in a number of different ways. So I just covered a few in this live stream, some of the more interesting ones I did. So if you come through in this Jupyter notebook that I actually did in this GitHub over here, I did a lot more here. So I covered those. I showed how to do some histograms here. I showed how to do some box and violin plots here. So I would advise you, if you enjoyed this live stream, go and check out the blog post, because I did a lot more in it. And unfortunately, I'm going to wind down the stream here because I don't think I could do much more talking. Yeah, so it was just a really fun, and you could create some really fun visualizations if you pick the right colors too. So with the pie charts that I created here, it was fun to see how like I created the orange versus the green. All these almost look like pumpkins a little bit. So you can do some really powerful things with Seaborn and Matplotlib. And again, this is within Python, and it is all open source, so I did not pay a dime for any of these things. So a huge thank you to the people who created Matplotlib and Seaborn. This is a really fantastic tool. Yeah, I am going to call it here. So I hope you all enjoyed this stream and its special Halloween kind of focus. In the next stream, we will get back to one of our other projects that we have been working on, most likely the computer vision rock, paper, scissors. So I apologize that I have not had many streams lately, and that's not for lack of trying. To be transparent, I have struggled quite a bit recently to get some of the stuff enabled for the computer vision rock, paper, scissors project. And that is just because, largely because TensorFlow is not really supported super well on the Apple Silicon Mac that I am working on. So the M1 based Mac. So it's been challenging. So next week there probably will not be a stream because I will be in Chicago. I am doing a run, the hot chocolate run. So that I did that last year. It was probably the funnest run I've ever done. It's a 15K where you start off in the heart of the city. You're running through skyscrapers. You run along. Oh my gosh. Please don't judge me for this. It's whatever the stadium is that the one football team plays at, or maybe it's not the football team. Soldier Field, that's what it is. So you run past that. You run past Lake Michigan. Really fun race, and then you get hot chocolate at the end. So I'm really looking forward to that. And then I'm also going to see a performance at the Chicago Symphony Orchestra. So I'm looking forward to that next weekend. So there probably will not be a stream If there is, it'll probably be from like a hotel room. And I've never tried to do like a mobile stream before, so I don't even know if I'll even try that. So anyway, I'm gonna wrap things up here because I'm not really feeling super well right now. Probably shouldn't have done this much talking. I hope you found this stream to be fun. I'm never gonna wear this hat on a stream again. This was just a fun Halloween treat for you. So I hope you all enjoyed this. I hope you all have a great and safe Halloween. And thank you very much for watching. We'll see you in the next one.